Hi and welcome to the lecture of the math. The goal of today's lecture is to show you how to read quadratic functions, and by saying how to read and comprehend, I mean that once you see some kind of expression, mathematical expression, so you could easily plot the function in your head and be aware of the shape of that function. I intentionally didn't put here anything because if I put, let's say, letter y, it automatically plots the function. So we don't need that because we are learning how to understand function first and have that plot in the head. So at the end of this lecture, quadratic functions will be the easy ones for you to understand. So let's start from the fact that all four functions here are quadratic functions. So quadratic function is defined by the x raised by the square. It doesn't mean that it shall have all the parts. Let's say here we have 3 parts, here we have 2 parts, here we have also 2 parts, but all of these functions are quadratic because we have x raised by power of 2. So general form of the quadratic function you might have seen is that one. So this is the general way it is expressed in the handbooks. So we can see that typical quadratic function has 3 coefficients a, b, and c, and these 3 coefficients fully define the function, how it looks on the coordinate plane. So if we make it appear and make all 3 coefficients as variables, you can see that in this web app we can play with these coefficients. So all 3 coefficients fully define the location and shape of the quadratic function. To demonstrate that, I will run animation which changes coefficients simultaneously in time. So I will launch all the 3 coefficients for changing, and as you can see, function changes its shape and moves in the coordinate plane. So to understand which coefficients does what, we stop the change and investigate one by one. So coefficient A is the coefficient which defines how wide or narrow branches of the function are. As you can see, branches can look down or can look up. It depends on the sign of the coefficient. If it's positive, then branches of the function looks up, and if negative, branches looks down. Then next coefficient is b. This coefficient is a bit, let's say, might look weird at the beginning because it moves a function left to right, and it might be difficult to understand that coefficient in the beginning, but later you will understand everything. So, and last one but not least is coefficient c, and this coefficient just raises function up or down, and positive value, or let's say increasing c raises function up, and decreasing c raises function down. So now you understand what each coefficient do to the function. Now fun part begins. Let's say that in that quadratic function we make coefficient a become a 0, and you can see that when it approaches 0, the branches stops being a branches because function straightens into the line. So when a is 0, you have just a linear function, and that's completely normal, because if instead of a you put 0, you have only bx plus c part, which is definition of linear function. And now is the most fun part of that lecture, is bx plus c. As you can see, if we take this bx plus c part and plot it as a separate function, you can observe very interesting behavior. You can observe that function bx plus c is a linear function, and it is tangent line to the quadratic function. If I run coefficients fluctuation again, you can observe that. So it's very beautiful relationship when green line is a tangent line to the function. And it might be not obvious, but if you want, I can create a separate video when I derive that tangent function from the quadratic one. Let me know about that. So most useful part of that property is that it is beautiful, and other thing, this property can help to define the sign of b coefficient. And as you can see, b is negative, and b is direction coefficient of the linear function. So if you look at the b coefficient, which was at the beginning is quite a weird coefficient and hard to understand, now you can see that it is also the direction coefficient of the linear function. So this can help you to understand the quadratic function better. So you know where the quadratic function, on what side it is located. For instance, let's try to predict. I will turn this off now. Let's try to predict where that function is located on the coordinate plane. Okay, so let's try to use our gained knowledge. Let's look at the first function. So what we know that a coefficient is 2, positive, so we know that branches goes up. Then we have b coefficient negative, so it means that tangent line crossing y-axis shall have direction coefficient negative. It means that tangent line should go something like that, and plus 2, it means that the function is raised by 2, so it should go something like that, and at point 2, which is c, cross the y-axis and then go up again, because branches goes up. I do not know it goes here or goes here, but I know that it is on the right side and branches going up. So let's check what we have. Yes, we have exactly what we predicted. Let's investigate second function. What we have here, so our a coefficient is -1, because we have minus x squared plus 2x minus 1, so a coefficient is -1. It means that branches of the function shall go down. Then we have b coefficient +2. +2 means that our tangent line, which crosses the y-axis, shall have northeast direction, something like that. And -1, coefficient c, it means that it shall cross the y-axis at -1. So we can expect something like that, or something maybe like that, but we know that function is located on the right hand side. So let's check that out. Yes, we have what we predicted. Great, let's go to the next one. In this case, we have 2x squared plus 2. So our a coefficient is 2, it's positive. If it's positive, our branches of the function goes up. Then we do not have a second term. like in functions above. It means that b coefficient in this case is 0, because if we multiply 0 by x, we'll get 0, nothing. So direction coefficient of linear function shall be 0, and 0 means that the function, let's say, tangent line is same line as x-axis, and then plus 2. So we know that a function is lifted by 2 units. So we should expect something like that. Our function branches up, goes from here, crosses y-axis at point 2, and symmetrically rises up. So our b is 0, so it should be symmetrical. Let's check that out. Yes, exactly. Okay, next function is this one. So what we can see, our a coefficient is -2. It's negative, so branches of the function must go down. Then next coefficient is b, which is near the x, so we have b coefficient equal to 3. 3 is positive. It means that function tangent line, which crosses y-axis, is directed in northeast direction, somewhere here. Okay, and we see that our c coefficient is 0 because we don't see it at all. So the only way is not see it is to have it equal to 0. So in that case, our function should go like that, something like that, something like that. Let's check that out. Yes, exactly, we have that shape. Good. Let's go to the last one. Oh, that is the last one. Okay, we already finished. So that's it about the functions. I think it was interesting and useful for you. So let me know if you want to see the proof video that this linear function is the true tangent of the quadratic function. Thanks, and till next time.